Morning, folks. We are going to look at operations on functions today. This is the first part of section 1.2 in our book. We'll do the second part in the next video. All right, so with operations on functions, what we're talking about are given functional notation. We talked about that in the last section where we have f of x or g of x or h of x, some function given to us. And say we want to add two functions. All right, there's a rule for this called the sum rule. I'm just going to jump in. There's like 4 or 5 different rules here we're going to go through. Actually, 4 that I can think of. Sum rule, the first one is f plus g of x. And you see it up here, f plus g of x is equal to f of x plus g of x. Now, again, these rules often don't mean a whole lot to you until you see them actually in use. So if I gave you two functions, what this comes down to is if I gave you f of x equals 2x minus 1 and g of x is x squared plus x minus 3. What this means, if they ask you for f plus g at x, it's literally just taking f of x, this piece, 2x minus 1, and adding it to this piece, g of x, x squared plus x minus 3. So what does that mean? Here, I put them in parentheses so you saw they were two separate quantities, but because it's all addition and subtraction, we can just combine like terms. So again, if I do what we normally do and go to the highest exponent first, we've got an x squared. I only see one of those. So I take that, put it down there. Nothing to combine it with is what I mean by that. Then we have a 2x and a positive x. Combine those, we get 3x's. Those are done. And then a -1 and a -3. Combine those, and we get -4. So this would be f of x plus g of x. So if they asked you for, say, for example, f of 2, or let's do something a little more complex than this. Let's do it combined in their notation. They may ask you for something like this, f of g of 2. And what that means is you can do two separate things. You could just use this function, or you could plug it into each one of these. So you could use it either way. The idea here is if we had a bunch of f plus g's at different values that we wanted, then it looked like it was negative, but it's equal. We could just plug it into this. We could plug it into this f plus g function and do this instead of having to plug it into each one of these and add that together. So we could do this substitution and end up with 4 squared, I should say, 2 squared, plus 6 minus 4. So what is that, 10 minus 4? That is 6. And that would be it. It's that straightforward. So again, just a basic rule. There's going to be a certain complexity added to this when we get into rational functions. I'm going to come back to that at the end. All right, so next, the difference rule. Much like the sum rule, we can do the same thing with f minus g of x. Again, if I use the same two f of x rules that we had 2x minus 1 was f of x, g of x was equal to x squared plus x minus 3. Now this is where if I want f minus g of x, I have to be careful because this is why I always do my substitution. When I think of f of x, I put it in parentheses as a substitution, and you'll see why in a moment. And then minus g of x, and our g of x is, again, in parentheses, this. And the reason this is important, especially with subtraction, is this negative needs to be distributed all the way through here. So we have to go through our steps. 2x minus 1, there's nothing in front of, nothing to power, so it's just that. But this negative is minus all of that stuff. So it's minus x squared, minus x, and then plus 3. That distributing the negative through there is incredibly important. It's the most common mistake people make when they're subtracting functions. So make sure you're aware of that. So now again, we start out our negative x squared, and then we have 2x minus x, 2x and a negative x, that is a positive x. -1 and a positive 3 is a positive 2. So this is our f minus g of x. So now we would get different values. Again, you could plug values in here easily enough. All right, this gives us a rule for this statement. All right, keep moving. We have the difference rule. Difference rule is, I'm sorry, product rule, not difference rule, sorry. With our product rule, we have a couple different things. It's the same idea again. It's just going to be f times g of x is f of x times g of x. Again, the two functions multiplied. So if I had those same functions again, and let's see, what did we have? We had f of x equals 2x minus 1, and g of x was x squared plus x minus 3. So now if we did f times, f times g of x, that's going to be equal to 2x minus 1 times x squared plus x minus 3. And we just have to multiply this out. You can use distributive property on this directly and list these out, but I'm going to use this as an opportunity to reinforce what I showed you the other day, which was doing long multiplication with polynomials. If I do that, I start out here with -1 times each of these. So -1 times -3 is a positive 3. -1 times x is a negative x. -1 times x squared is a negative x squared. Then 2x times a -3 is a negative 6x. And then 2x times x is a positive 2x squared. 2x times x squared is 2x cubed. So now, and again, what we did there was then go to this one, and that's where we got this row right here. All right. So finally, what do? Notice I kept those in columns by their exponent so that we can just add straight down, and that was supposed to be an arrow. So we've got 2x cubed. -1 plus 2 is a positive x squared. -1 and a -6 is a negative 7x. And then we have a positive 3. And that would be what we'd call f times g of x. And again, you can plug values in there, just like we did with the other stuff. So next, we are going to go to quotient rule. And if my machine will cooperate here. There we go. All right, quotient rule. With our quotient rule, we are going to have, again, the same idea. If they show you f over g of x, that's f of x over g of x. But I want to use some a little more complex examples here. If I gave you f of x equals, let's say, x plus 2, and g of x equals x over x minus 1. We have to be careful. Remember, this becomes rational, a rational function. And in fact, one of the functions itself is rational. And we talked about this in previous sections. When we have a rational function, we can't have 0 in the denominator, right? So automatically, we know when we look at anytime we're given any function, we create a new function. That's what we're doing with these rules. We're creating a new function, f of g of x, f times g of x, f plus or minus g of x. All of those are new functions. We always have to consider any values that are now excluded. Remember, we talked about excluded values of the domain. So, for example, this domain here has the value, the domain itself is all real numbers, where x is not equal to 1, right? Because 1 would make that 0 in the denominator, can't have that. So automatically, our new function cannot have x equal to 1 in its denominator either. It's excluded from the domain because it's excluded from the domain of one of the functions. So the function that is a combination through operations of f over g of x would also have to have that excluded. All right, so automatically, when we write this new function, we have to tell the excluded values. So let's look at this now. If I want f over g of x, that's going to equal f of x, which is x plus 2 over x minus 1. So again, remember I talked about this rule with fractions. If you have a fraction, you flip and multiply to divide by it. So if you have any kind of rational expression like this, in the denominator, we flip and multiply. So we think of x plus 2 as x plus 2 over 1. And then we're going to take the reciprocal value of the denominator and multiply it, because division and multiplication are reciprocal operations. So when we multiply this, on top, we're going to use FOIL here. We've got x squared, then we've got minus x, multiplying these two, and then a positive 2x. So that's going to be plus x, right? This is plus 2x. This is minus x, so we get a positive x. And then 2 times negative 1 is a negative 2. And then all of that is over x. So our f over g of x would be equal to x squared plus x minus 2 over x. Now, remember, we said we always have to tell excluded values. You don't have to tell the whole domain. We don't say all real numbers. We just have to guarantee, we have to say x cannot equal 1. But there's also another value now. Look at this composite function we have here, this function that's composed of these other two. That's f over g of x. We look at this rational expression and say, well, we can't have 0 in there either. If x is 0, we're also in a world of hurt here, right? So we can't have 0 as well. So we have to be very clear that this is our completed solution. We have x squared plus x minus 2 over x not equal to 1 or 0. All right, and let's keep going here. I want to give you another example where this can become a problem. You may not think of it as this, but we had before, we were looking at f of x minus g of x. Or as we were seeing, they would do it this way, f minus g of x. Well, I want to give you something that involves a rational function. So if f of x is x plus 2, and g of x is x over x minus 1, those two we just use, we automatically know that f minus g of x, this again is combining two functions using an operation. We already know x cannot equal 1 for this rational expression. So now when we want f minus g of x, we have to take that into consideration. We've got x plus 2, and I want you to think of that as over 1 minus x over x minus 1. This is not fully simplified, and this is the problem. Remember, we always want fully simplified solutions. So what we have to do is find a common denominator. And the way we do that is we look at this denominator as x minus 1. This one is just 1. So I want a common denominator of x minus 1. So I'm going to multiply top and bottom by x minus 1. When I do that up here, I get x squared plus x minus 2 from that last result over x minus 1. And then minus x over x minus 1. So what can we do here? Well, let's look at it. We had, let's see, that's all right, that's right. All right, so now what we have is x squared plus x minus 2 minus x all over x minus 1. So what is that going to give us? Well, again, let's see. Sorry, guys, I had someone walk in the room. So we've got x squared plus x minus x. Those are going to cancel. So we'd end up with x squared minus 2 all over x minus 1. Now, we have to include the fact that x cannot equal 1. That came right from here, but it's also in the final result, right? So the key concept here is that once we get this is bothering me. This is real sloppy up here. Sorry, guys. This is times x minus 1. All right. So this result is something we can use if we need f minus g of x for any value. We can plug in any value for the x's. More importantly, it's fully simplified. We have fewer substitutions, fewer things to work with here than what we started with. You have to fully simplify this. You have to find that common denominator, multiply through, and then combine those terms over that single denominator. All right. And that's pretty much it. That's all for this stuff, guys. Have a wonderful day, and I'll see you in the next video.